Here are a couple examples of doing polynomial long division. So here's our first one, 3x squared minus 2x plus 1 divided by x minus 2. The thing about polynomial long division is it works basically exactly the same as dividing integers. So let's get this set up. Our dividend, it's called, is 3x squared minus 2x plus 1. And we are dividing that by x minus 2. So just like with integers, the first thing to do to figure out what goes right here is to ask ourselves what times x would give us 3x squared. So basically you compare the big parts and ask what times the big part gives you the big part of your dividend. So to get 3x squared from something times x, we need 3x. So now we multiply. 3x times x minus 2 is 3x squared minus 6x. And then, just like with integer division, we subtract that. And the big parts right here, when you're talking about polynomials, the bigness is really talking about degree. So the big parts, the degree 2 parts, should cancel. And sure enough, they do. 3x squared minus 3x squared is 0. So the big part's canceled. And then minus 2x minus negative 6x is plus 4x. It's easy to forget that this minus sign distributes to the minus sign in front of the 6. So careful there. And plus 1. Okay. Now we have to ask ourselves, are we done yet? And to check if you're done, you ask yourself, is the big part on our remainder, which is degree 1 right now, smaller than the big part in our divisor? So is degree 1 less than degree 1? No. So keep going. Do the whole thing again. So now we ask ourselves, to get this spot right here, our second term in our quotient, what times x would give us 4x? And that's plus 4, of course. And now we multiply. 4 times x minus 2 is 4x minus 8. And then we subtract. 4x minus 4x is no x's, so the big part canceled again. And then 1 minus negative 8 is plus 9. And then we ask ourselves, are we done? Is the degree of our remainder less than the degree of our divisor? Yes, our remainder is now degree 0, and that's a lower degree than our divisor, which is degree 1. So now we're done with our division. So our result is 3x plus 4 plus our remainder. And just like with integer division, the remainder is the remainder over the divisor. Okay, so there we go. Now, if we wanted to check this, we could take this whole quotient and remainder part, this entire right-hand side, put it all over the denominator x minus 2. Whoops, this 3 here should be a 2. If we put all of this result over the denominator x minus 2 and then added all these fractions together, we would get back to the quotient that we started with. So if you want to check your work, that's how to do it. For our second example, we're going to do this, x cubed plus 1 over x cubed minus 3x squared plus 2x. And the reason that we're looking at this one is because this is from the homework on partial fractions. This is from section 7.4, and it's number 3b. So if you haven't tried this one yet, I suggest that you pause the video and see if you can work out this quotient on your own, given the example that we just looked at. The reason that we have to do long division on this before doing partial fractions is because to write down a partial fractions decomposition, the degree of the denominator, which is 3, has to be strictly less than the degree of the numerator, which is 3. Well, 3 is not strictly less than 3, so you cannot write down a partial fractions decomposition of this yet. First, we need to do long division so that the remainder term has a lower degree in the numerator than the denominator. All right, so we've decided We need to do long division here, so let's get it set up. X cubed minus 3x squared plus 2x. And we are dividing by, I've got that backwards, of course. We are dividing x cubed plus 1. We are dividing that by, oh, I didn't leave myself enough room. X cubed minus 3x squared plus 2x. Oh, it just barely fit. Okay, now you notice I left a lot of space in the middle here, and that's because as we do this division, there will be all of the missing powers of x will show up in our computation. So I'm just leaving room for them here so that things don't get too crowded later. All right, so now we're going to play our quotient game here. To figure out what goes in this spot, we ask ourselves what times x cubed gives us the big part of the dividend. So what times x cubed is x cubed? Well, that's 1. And now we multiply. 1 times the whole divisor is x cubed minus 3x squared plus 2x. You can see those intermediate powers of x are showing up now in our calculation. So after you multiply, you subtract. X cubed minus x cubed is no x cubed, so the big part canceled again. And then 0x squared plus 3x squared is 3x squared. And remember, it's plus because we have a minus sign over here because we're subtracting, and another minus sign there because that minus sign was there to begin with from the divisor. Okay, and then 0x squared minus 2x squared is minus 2x. I'm sorry, 0x minus 2x is minus 2x. And then plus 1 minus, there's no constant here in our product. So, all right, now we ask ourselves, are we done? Is the degree of our remainder less than the degree of our divisor? Yes, we only had to do one round of division here, and already we're done. So that means that the quotient that we started with is 1, our quotient, plus the remainder over the divisor. So 3x squared minus 2x plus 1 over x cubed minus 3x squared plus 2x. All right, and just like last time, if you do want to check that this is correct, you can just put these two terms over a common denominator, and when you do, you will get back the quotient that you started with, or at least you should if we did the division correctly.